So let us start with fundamental theorem of arithmetic. So here what is fundamental theorem of arithmetic means here? Every natural number except 1. Okay, so here except 1 can be factorized as product of primes, and this factorization is unique except for the order in which the prime factors are written. Okay, I'm gonna explain you how is this work. See, every natural number except 1. I'm removing the number 1 from natural number. We know natural number is listed as 1, 2, 3, 4 and so on. So I'm removing only the first number, okay, 1. Apart from the first number, all other numbers can be factorized as product of primes. This is nothing but composite number. Okay, so product of prime in the other sense we can call as composite number, and these factorizations, all these factorizations is unique. It must be unique only one times. Okay, it should repeat. So except for the order in which the prime factors are written. Okay, what does it means except the order in which prime factors are written? So we know that prime factors are, right? So what are the prime factors of 24? Prime factors, I said only prime factors. Okay, so we know as 4 6 are 24. In this also we need to take only prime numbers. This 4 can be split into 2 into 2, and this 6 can be split into 2 into 3, right? So what are all the prime factors? You have to collect all those things, and that should be unique. Okay, so not in more than one factors. Okay, so factorization is unique. So 2 has a 3 times, that is nothing but 2 raised to the power 3, and this is unique now. And also the order in which the prime factors are written. Okay, so except the order, in the sense here we are writing 2 after 3 and then next consecutive. Okay, next consecutive prime numbers. So which mean order here is prime factors. Got it? Okay, so 2 to the power 3 cross 3 is a prime factorization for this 24. Okay, so for 24 we can write 2 cube 8 times 3. We can also say 3 times 8 is also 24. That is also no problem. Okay, so here it is listed in this way. So this is a formula for fundamental theorem of arithmetic. Okay, see what here it says. N here is composite number. It is a composite number. Always remember it is a composite number, product of primes. Okay, so what here we have? So P1 raised to the power P2, P2 raised to the power Q2, and so on. It is product. So this cross is a product. Okay, product means multiplication. So Pn, nth term, in general we say nth term, it may be 100 or 1000, whatever you want you can keep. Okay, so Pn raised to the power Qn. Here where I have written P1, P2, Pn are in the form of prime numbers. Yeah, thus we have here. So here P1 is equal to 2, P2 is equal to 3, and here Q1 is equal to 3, Q2 is equal to 1. Okay, so P1 is 2, P2 is 3, Q1 and Q2 are 3 and 1. No matter how it shuffles. Okay, either 3 comes first or 1 comes first, it doesn't matter in the power. And Q1, Q2, Qn are natural numbers. They are natural numbers. They should not be negative. Okay, let us go for some of the examples so that you can understand it clear. Let us take another one. Let us take 36 or 26, whatever you want you can take. 26, this 26 can be written as 13 into 2 times, and this is power 1 power 1. So both are represented in this manner. Okay, so P1 power Q1, P2 power Q2, and this P1 and P2 should be prime number, and to raise to the power, or powers will be in natural number. Okay, so some other examples. Let us say 15 or 17 is exactly prime numbers. We need product of prime numbers, right? So other thing, 34, let us take 34. 17 into 2 is 34, so power 1 power 1. So for 15, 3 times 5 is 15. Yeah, got it, right? So then what about 36 here? 36 is 6 times 6, and this 6 can be further written as, even though we can write 18 into 2 is 16. So 3 into 2, again 3 into 2, these can be written as 2 square, 3 square, right? 2 square is 4, 3 square is 9, so 4 nines are again 36. So we can write in this way. Okay, so here P1 is 2, P2 is 3, Q1 and Q2 both are same. Okay, these all belongs to natural number and P1 P2 belongs to prime numbers. Let us move to the next topic. So fundamental theorem of arithmetic is nothing but we just need to write the composite number, any composite number in this manner, P1 power Q1, P2 power Q2, in this manner. Okay, so as we know 3 8s are 24, so 3 to the power 1. We can write any composite number in this manner. So that is what the fundamental theorem of arithmetic says. Okay, right. Let us go for third one. So let us start with exercise. So exercise 2.2. So 2.2 for first question. For what? Values of natural number n, say n, natural number n, 4 power n can end with the digit 6 in the last. Okay, so let us have this solution. So and it is an easier one also. See, 4 power n can also be written in 2 power 2 times 2 power n. That means 2 is also a factor of 4. Factor of 4. Can we say like this? 2 is a factor of 4 apart from n. Also for n equal to 1. See, for n equal to 1, for n equal to 2, n equal to 3, n equal to 4, n equal to 5 and n equal to 6. Okay, so I'm just writing for n equal to 1, 4 power 1 it is 4. For n equal to 2, 4 square is 16. It's end up 6, ending up with the 6. Okay, so this is okay. So 4 cube 64, 4 power 4 is 2, 5, 6. It ends up with the 6. Again this is okay. So 4 power 5 will not work because every odd number does not work. 1, 3 and 5 will not work. And 4 power 6 is, if you want you can check, 4 power 6 is 4096. Okay, 4096. And it ends up with the 6. Okay, for every even natural numbers of n, this 4 power n can end with the digit, last digit is 6. Okay, so we can say for what value of n? For n equal to even natural number, or you can say 2, 4, 6, 8 and so on. 4 power n can be ended with the digit 6. Okay, so this was the first question and it is very easier to you. By looking at, you can tell that. Just you have to try the version n equal to 1, 2, 3 and so on. There's a fifth question. So in exercise 2.2 all the questions are easy, just you have to apply the LCM and GCD. Once you know the LCM and GCD, how to operate with that, where and how to operate, once if you know this, you can do easily all the problems. Okay, I'm just giving you the simple way technique. So this is based on first fundamental theorem of arithmetic. Okay, so P1 power x1 times P2 power x2 times P3 power x3 times P4 power x power 4. We need to find and this is equal to 113400. We need to find x1 equal to x2 equal to x3 equal to x4 equal to P1 equal to P2 equal to P3 equal to P4. All these things we have to find. First for x1 to x4 is belongs to natural number and the other one belongs to prime numbers. Okay, prime number. NO means number, so prime number. And let us begin this. So 113400. So I just begin with 2 because 0 is ending with number and you have to keep that in mind, whichever the number divisible by given number. Okay, these are all the basic thing which comes in earlier. 6th or 7th standard, you should be careful for this one. Okay, so do 5 times 10 and remainder 1. Again do 5 times 10, remainder 3. Okay, so again do 1 times 2 here, or yeah, or we can say do 15 times 32, 16 times 32, do 17 times 34, 20 times 0, 20 times 0, 1 0, right? So 2 7 times 14, 2 is the 2 plus 1 3, so 2 5 times 10, so 2 5 times 10 plus 1 is 11, so sums of 14 and double 0, right? Correct, got it. So 5 5 1 7 0 is there. Rather than doing that, see 2 5 times 10 and remainder is 1, 2 6 times is 12, right? Yeah, 2 6 times is 12, remainder is 14, so 2 7s are 14, remainder 2 zeros. Got it. Next again 2 times is 4, remainder 16, 2 8s are 16, 2 next 2 3s are 6, remainder is 1, 2 5s are 10, and then 0. Next again 0 rise up, so 2 14 times 28, 2 1 time 2, remainder 15, 2 sums are 14, remainder 10, so 2 5 times. So here's a 5 here, I'm using 5 again here, so 5 2s are 10, so 5 2s are 10, remainder 40, so 5 8s are 40, remainder 17, 5 3s are 15, remainder 35, so 5 7s are 35. Got it. So I'm using 3 now. See 3 8s are 24, 3 9s are 27, 27, so remainder 33, 3 4s are 12, remainder 17, something is not doing anything, so okay, so 3 9s are 27, remainder is 3 4s are 12, and if okay, let us do in this way. 3 4s are 12, so remainder is 27, 3 7s are 21, 3 2s are 6, 3 5s are 15, again 3, so 3 1 times 3, remainder 17, 3 5s are 15, remainder 22, so 3 7s are 22, 3 5s are 15 again. Got it. Again 3, so 3 5s are 15, 3 2s are 6, 3 5s are 15, so 3 1 times 3, so 3 1 times 3, remainder is 23, yeah, okay, so 3 7s are 21, remainder is 2, sorry 1, so 15, 3 5 times 15 again, so let us have again with 3, so 3 6 are 18, no, let us have with this 5, okay, also on 5 with 5, so 5 3s are 15, remaining 25, 5 5s are 25, so 5 7s are 25, sorry 5 7s are 35, 7 will be 1 time. So what are all the things which we got here from least number 2, and P1, P2, P3, P4 should be in ascending order, he has given in the question, okay, no problem. So these 2, 3, 5 and 7 ones, okay, so P1 equal to 2, P2 equal to 3, P4 equal to, sorry, P3 equal to 5 and P4 equal to 7. Got it. Now can we write this in this form? 11 3 4 0 can be written in this form. 2 power 3 times 3 power 4 times 5 power 2 and 7 power 1. That means we already know the p values, and now x values are x1 equal to 3, x2 is equal to 4, x3 equal to 2 and x4 equal to 1. Here you goes. So this was your final answer. All the x values and p values are got it only through the prime factorization of 2, 3, 5 and 7. Okay, and this was a composite number 113400. Okay, let us go for the last question. And your last question is 9th one. Find the least number. That means he is asking LCM that is divisible by first 10 natural number. Okay, so that is divisible by first 10 natural number. Okay, 10 natural numbers. Right, let us have this LCM. So I'm gonna take LCM for 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Got it? So for 1 we don't need, it is already in 1. So for 2, let us take with 2 1 times. So this is not going to divide. So 2 times 4, 5, 2 3 times 6, 2 4 times 9 and 2 5 times. Got it? So let us take another one. So 2 1 1 3 1 5 3 7 2 9 5. Let us take again 2 1 1 3 1 5 3 7 1 9 and 5. Let us take with 5 again now. There are 3's also there. So 3 1 1 1 1 5 1 7 1 9 is there, right? So 3 times 9 and 5 again. So another time will rise up 3. So 1 1 1 1 5 1 7 1 3 1 times 3 and then 5. Now take for 5 1 1 1 1 1 7 will stay here 1 1 and 1. If you take another for 7, all the things will be in 1, and these are the LCMs which we have. So LCM is equal to 1 2 3. So 2 power 3, 3 power 2, 5 power 1 and 7 power 1. So even though if we have this, LCM is also in the form of composite numbers. Okay, so 2 cube is 8, 3 square is 9, 5 sevens are 35, 9 eights are 72 times 35. So 72 35 will be 7 threes are 21, 7 fives are 35, 8 twos are 6, so 41 10. So your answer will be 2520. Got it? So this is how it works. So the 9th one is very easier. So you just need to find the least number, and that is least common multiples LCM of the first 10 natural number. So first 10 natural number LCM will be 2520, or you can say 2520. Got it? So inshallah we will see the exercise 2.3 next.